Welcome to the pigeonhole principle. So the definition is if n plus 1 pigeons want to occupy n holes, then at least one hole must have more than one pigeon in it. Hopefully that makes sense. So to use these examples with numbers rather than just the algebra. So if you had 7 pigeons, but there were only 6 holes available, then one hole must have at least 2 pigeons. So obviously the 6 holes get filled by 1 pigeon each, leaving 1 pigeon left over, which means that that pigeon must go into one of the other 6 holes, giving at least one of them 2 pigeons. If you have 6 holes, how many pigeons must you have if at least one hole has 3 pigeons in it? So this is asking the question just in the opposite way. And this is what we tend to get in our HSC exams. So each of the 6 holes can have 2 pigeons in it, so that's 12, and therefore one more pigeon would mean that at least one hole has 3, so therefore 13 pigeons would be required, so that you got at least one hole has 3 pigeons. So if there were 4,456 people eligible to vote in an election, and there are 12 candidates, and each eligible member, so all 4,456 have to vote for at least one of the candidates, what's the minimum number of votes required to win the election? So we're going to assume that all 12 candidates get pretty close to the exact amount of votes each, but one's going to win based on the having more votes than the others. So if we divide straight, so let's go straight to 4,456 divided by 12, that gets 371.3 recurring. So that means that every single candidate, if we want there to be the least amount of votes to win, every single candidate has to get 371 votes each. So then the leftover votes are what can go to someone else. So if everyone gets 371 each, that's 12 lots of 371, which is 4,452. So that means that we then have 4 votes left over. So for those 4 votes, if we were to give a vote each to one candidate, so give 2 candidates a vote each, that takes care of 2, and then give one candidate 2 votes, that means that that candidate then wins the election with 373 votes. Thank you.